Hello students, now we're looking at linear models. So we're going to take our equations of lines and now look at modeling real world situations with this. So this is syllabus topic 6.2, and let's first think back to our equations of lines. So looking at each equation, we've got our three different forms. Well, this is almost standard form. What do we know immediately about these separate lines? So looking at this first one, I could say straight away that this line has a slope of 1/2, and I remember that that means it's a positive slope. It's going to go to the right one up 2 from any given point, and so I'll have some sort of slope like that. I can also see this -17, that's going to be my y-intercept. So this line is going to go through the point 0, -17. All right, for this line, 2x minus 4y equals 16. Well, I want to think about things that multiply and make 16. So I know that 2 times 8 is 16. So if I had 2 times 8 minus 4 times 0, that would be 16. So that tells me this point 8, 0 is on the line. And I like the zeros because this is now my x-intercept. Thinking about if this was 0, then -4 times -4 would give me positive 16. So I must also go through the point 0, -4, my x and my y. So there's my y-intercept. So looking at this equation, I know the x and y-intercepts. That could also help me think about a sketch. So my x-intercept is 8, 0, y-intercept is, -4, 0. So I can see that this line also has a positive slope. And from that, I could calculate my slope. Up 4 over 8, it's actually the same slope. All right, this line over here, I can see straight away has a slope of -1/3. So that tells me that my line is going to go from any point down 1 over 3. So now I have a negative slope, and it's a bit flatter than this line. I can also see a point. So this line goes through the point -2, +5. Remember, we always do in point slope form y minus y1 equals slope times x minus x1. So since this is +2, my x value must have been -2, and my y value must be +5. So this line has a slope of -1/3 and goes through the point -2, 5.